so yesterday we dismissed this as an impossibly annoying parameterization. So of course when you ask for a parameterization question, I'm going to say, let's do the impossibly annoying one from yesterday. So this is a, what?
Cylinder.
Yeah, cylinder, right? I want to parameterize the intersection between a cylinder and a plane. So that's going to be what? Yeah, it's going to be one of two things. It's either going to be a circle, right? Or maybe a pair of lines or a single line or something, or in this case, an ellipse, right? But of course, that ellipse is slanty. You guys see that? So I'm thinking, all right, I got my cylinder, and then I got my plane cutting through it, something like this. Okay, so I said this was impossibly annoying. I kind of lied. It's not too bad. What do you do? Huh, weird.
Yeah, what?
Okay. Hold on a minute. Oh, I have your pen too. So, intersection? How? Oh. Homogeneity. How about this? What do you start with? You got a cylinder, right? What's a cylinder look like? Like, what's the equation for a cylinder look like? What do you guys always want to say those are?
Circles.
Yeah, you always want to say it's a circle, right? Okay, so underlying this thing is a circle, yeah? So what does that suggest I should use as a parameter?
Sines and cosines.
Yeah, sines and cosines, right? Okay, so I'm looking at this thing, and I'm kind of thinking to myself, all right, circle, even though it's not. So circle means having to think betas, right?
Cosine theta squared plus sine theta squared equals 1.
Forget the R's.
Perfect. So cosine squared theta plus sine squared theta is 1. That's that Pythagorean identity. Hey, this thing looks like that thing, right?
Yep.
So what are you going to let x and y be?
Cosine and sine.
Okay, so if I let x be cosine theta, I let y be sine theta.
Forget the R.
Where's the ellipse part of this coming in now?
Their coefficients are different.
So either I could adjust the coefficients on these, right? But I need x and y to satisfy x squared plus y squared is 1. So do I get to adjust the coefficients on x and y?
No.
Nah. So where's your ellipse coming from?
Z plus y equals 2.
Yeah, right? Z plus y has to be 2 for it to be on this thing.
We can make z equal, y equals z minus 2.
Okay, so maybe, how about z is 2 minus y? If z is 2 minus y, then what's the z value in my parameterization have to be?
2 minus sine theta.
2 minus sine theta. Perfect.
Why wouldn't we use the x equals r cosine theta?
What's the radius of the cylinder?
It's unit, it's just one leg.
Yeah, it's 1 radius, right? So what am I doing with this thing? I'm thinking, down here there's an angle, right? Like here's the x-axis. There's this angle theta down here, right? That's driving my x and y values. And then where am I getting this curve from? Right now I'm just kind of thinking, okay, I'm just going to go around a circle in the xy plane, right? That's really me thinking z is 0. But z's not 0. Z's 2 minus y. So I just got to adjust the height. You see that? So here's your cylinder, or your ellipse. And how do I write this thing? What should I summarize?
Oh, r theta.
Sure. Name your parameterization something, right?
R theta equals cosine theta sine theta 2 minus sine theta.
Perfect. Cosine theta, sine theta, 2 minus sine theta. Is it obvious this thing's an ellipse?
Not really.
Not particularly. Is that okay?
It's fine.
Yeah. Does it satisfy the two equations it's supposed to?
Yeah.
Yes.
Right? From these two, I know that x squared plus y squared is 1. And from these two, I know that z is,
And a lens.
or z plus y is 2. Check. Cool. And then maybe if I thought about to go around once, sure, 2 pi, right?
Zero.
Okay. Which way have I oriented this thing? Like if I was going to use this for a line integral, which way does it go?
Upwards.
Upwards. It's a line, bro.
That's a line. Wow.
Right? It's this circle.
Oh.
Am I going around it this way, or am I going around that way?
I'll counterclockwise.
Counterclockwise. Yeah, I'm going backwards, this way. Cool. You guys all see that? Which is right-hand rule, right? Yeah, for upwards. So if I was going to use screens, well, screens apply here?
Yeah, yeah.
No, it's not two-dimensional.
No, it's not two-dimensional. So I have to use, what's the
Stokes.
three-dimensional version of greens? Stokes.
Okay.
So if I was going to use Stokes, right, to do this line integral, right, the orientation I've given my curve would go with pointed upward on that surface.
Okay.
Cool?